Yeah.
Hello everyone. So this is team the Minions, and this is our Sprint3 presentation video. And let us introduce ourselves first. This is Lingy.
Hi, this is Deepika.
Hi, this is Christiana.
Hi, this is Vaishnavi.
Hi, this is Yash.
Hey, this is Ramesh.
Hi, this is Yukon.
Hi everyone, this is Grishma.
All right, then we can start.
Yes.
This is our agenda for today's meeting. And these are our team members. I guess we already introduced ourselves. These were the improvements from the sprint 2. We had few feedback from the professor, like we had some corrections in the user stories, and we have to add it average line to the team velocity chart, include API slides in the sprint presentation, etc. So we hope we have done all those improvements in this sprint. So coming to a problem statement, medical imaging plays a crucial role in diagnosing severe health conditions such as pneumonia and brain tumors. However, accurate interpretation of lung X-rays and brain MRIs requires skilled radiologists. Due to human errors, time constraints, and variations in expertise, can lead to delayed or incorrect treatments. Additionally, in many regions, there is a shortage of radiologists and healthcare professionals, making early diagnosis and timely treatment difficult. So to solve this problem, we propose Image Medics. This project aims to develop an AI-powered web application that can automatically detect pneumonia in lung X-rays and brain tumor in MRI scans with high accuracy. So this system will enable healthcare professionals to upload images and receive instant AI-based diagnostic results. It provides a unified platform for detecting both pneumonia and brain tumors. We are utilizing deep learning models like ResNet model and EfficientNet model for efficient image classification and analysis.
This is a description of our project Image Medics was developed by our team, the Minions. It is designed to help healthcare professionals diagnose pneumonia and brain tumors faster and more accurately. We created a system called the Dual Stage Medical Image Classification System, which analyzes lung X-rays and brain MRIs in 2 steps to provide an accurate diagnosis. Unlike older systems that can only handle one type of image, our platform supports both types, making the diagnostic process quicker and easier. This saves time, reduces mistakes, and helps hospitals that may not have many specialists make faster, better decisions. You can find more details about our project through the GitHub link we have provided below. Next slide will be explained by Deepika.
Yeah, coming to the team working agreement, our team created a simple agreement to stay organized at work and better together. And coming to the responsibilities, each member is responsible for finishing the task on time and telling the team if there are any problems. Communication, we had communication through WhatsApp, Discord, and emails for fast communication, and meet weekly to review progress. Meeting attendance, like everyone is expected to attend the meetings, and we followed and we catched up if there are any missing in the middle. Coming to the collaboration, everyone is expected to collaborate each other, and by giving feedback to each other, we are having the collaboration in groups and connecting deliverables. We agree to deliverables, presentations, updations, documentations regularly with peer reviews to maintain quality. Code and documentation, code must be clean and easy to understand, and so that we can document and update them. um, Next, decision making. Decisions are made together during meetings, and by taking to the consideration of majority, we went through uh, if there are any disagreements. Coming to conflict and resolution, um, conflicts are discussed openly, and if not solved, we ask for the further helps. Yeah.
And here comes to our personas. We have three personas here, and this is our first one. So this is Dr. James. He works as a senior radiologist in a hospital. So his biggest problem is he has too many images to check every day, right? And this causes delays and stress sometimes. Our systems helps by doing the first check automatically, so he can focus on the tough cases. And here it comes to our second personas here, and she's Dr. Susan. She works as a family doctor in a rural clinic. So she wants to help patients in remote areas, but finds it's hard to spot complex issues like brain tumors on her own. And our system gives her quick answers about brain and lung scans, helping her make better decisions for her patients. And this is our third personas here. He's Dr. Raj, and he runs hospital. So his big challenge is not having enough radiologists, and which means like patients might wait too long for results. So our system speeds up diagnosis across his hospital, especially helping the smaller ones with fewer resources. And here it comes to our MVP. And you can see from the page, our system has uh, six main features. And first, it stores images as either long X-rays or brain scans, then checks for problems, and it uses AI to find abnormalities and tells you how sure it is about its findings, and also handles both lung and brain images in one place. So, users, doctors don't need different tools, and it's very easy to use. Just upload an image and you can get the results you want. It's also fast while still being accurate. And it generates simple reports to show what was found and what to do next. And next slide will be explained by
Hey, I'll explain the
yes.
technologies. In technologies, we use like front end, it's React.js user to create a user-friendly interface that allows healthcare professionals to upload and view medical image easily. And the backend we use Node.js, Flask, and MongoDB. In Node.js, it handles API requests and manages communication between the front end and backend services. And in the Flask, it supports model interface by running machine learning models for image classification and diagnosis. And for the MongoDB, it uses stored user data, images, and diagnostic results, enabling secure and scalable data management. And the machine learning, it built using PyTorch and trained on datasets for lung X-rays and brain MRIs. In cloud infrastructure, we use deploying using AWS. And coming to the algorithm. So yeah, coming to the algorithm, the system uses to core algorithm is based on a pre-trained deep learning models. A recent model fine-tuned data sets of medical images is used to classify whether the uploaded image is a lung X-ray or a brain MRI. Depending on the classification result, the system proceeds to a second stage. And for the lung X-ray, a fine-tuned, efficient net model detects and classifies pneumonia into normal viral and bacterial categories by analyzing the lung patterns. So these models provide high accuracy and efficiency, ensuring reliable diagnosis for both images.
Hi, this is the architecture diagram which displays the overall structure of a system, showing its component, their interaction, and the data flow between them. The user interacts with the web app, which acts as the main interface. The web app coordinates between the various components, like it sends the upload image to the AI classification modules, which process the image using the trained module. AI classification module returns the diagnosis to the web app, which displays the result to the user. The web app also stores the important data in the database for record keeping for future analysis. Next slide, please. This is the context diagram, which represents the system at high level, focusing on how the system interacts with the external entities like user, system, and AI model. The user upload the image to the system. The system process image by sending it to the AI model. AI model process the image and return the diagnosis, which the system relays back to the user. Next diagram, please. This is a ER diagram model a medical system where doctor upload the scans, generate reports, and consult patients. There are four main entities: doctor, patient, scan, and report. Doctor can upload images. Doctor can upload multiple scans and create reports based on the scans. Patients undergo scans and can consult multiple doctors. Each scan is linked to the specific patient and is used to generate report. Reports contain diagnoses and are created by the doctors. The relationship ensure proper data flow with the foreign key maintaining connection between scans, patients, doctors, and reports. These setups help in efficient managing medical reports and doctor-patient interactions.
Yeah, this is sequence diagram. As you can see, the users can upload images to web app, and the web app can display the diagnosis to users after process images and get the diagnosis from AI model, because AI model will process those images. And also, web app can store the result in database, and this is sequence diagram. And next one is state diagram. As you can see from the top, users can start and logged out. If not logged out, no.
Sorry.
And if not, if you can successful login and you can upload images. If you can see that's a cycle. If you upload images not successful, you can retry. And after login, after you upload images, you can process images and view diagnosis. You will return diagnosis to users, and also you can view past diagnosis. You will return users to dashboard, and this is state diagram. And next one is class diagram. As you can see, this one is a little complicated. From the left, doctor can use this scan upload model. There are some attributes here. You can see ID, names, specialization, upload, scan, view results, and manage patient history. And use this scan upload module. You can scan and upload. And top one is patient management module, and you can store the patient information, like current patient list, as you can see. And after that, you can send requests to API gateway. You can use some functions inside the API and validates requests to the authentication service on the right, like verify credentials, generate tokens, validate access. And from the patient row, and there are four attributes: ID, name, medical history, scan history, and you can use this. Also use scan upload module. Select files, validate files, submit it to backend, and upload to scan, yeah, also to API gateway, and send requests to authentication service. And from the top one, that's route request to scan service, and send images for analysis to turn classifier, and access to historical data. That's like past diagnosis. Store those data in database, and finally, you can return to the user, and you can view it. This is class diagram.
So this is a Sprint 2 recap. So in Sprint 2, we implemented image upload, automatic AI diagnosis, and result storage features. User authentication and backend API integration were also completed. So we also did some stories that were carried over from Sprint 1, like static UI and simple upload were finalized, and then Sprint 2 successfully delivered critical system functionality. Now we'll be going into the sprint tree. So this is the product backlog. So product backlog is a list of all the key features and tasks we plan to implement in our project. It helps us to stay organized and prioritize what's important. So we rank the items based on what brings the most value and what we need to build first for the minimum viable product MVP. For example, like uploading images and detecting diseases are a top priority. So the backlog is a living document. As we progress through sprints and get feedback, we may add new items, adjust priorities, or remove things. Every sprint, we pull items from the product backlog into our sprint backlog depending on team capacity and deadlines. User story is a simple description of a feature from the user's perspective, answering what they want and why they want it. And every user story is associated with an acceptance criteria. These are the conditions that need to be met for the user story to be considered complete. They focus on ensuring the functionality works as intended and meets the user expectations. Yeah, you can scroll down. All of this is a product backlog.
Uh, yeah, coming to the recap of Sprint 1 burn-down chart. In Sprint 1, we started a bit late, which initially delayed progress. As the sprint moved forward, we gained momentum and began completing user stories. However, we faced a few hiccups along the way due to forensics, forensics complexities in implementing key features. These challenges impacted our ability to finish all planned work within the sprint. As a result, some user stories had been pushed to sprint 2. But the burn-down chart reflects this journey, showing a slow chart, some progress in the middle, but ultimately not reaching zero story points. By the end, our completion rate for the sprint one was 70.59%, which highlighted the need for better planning and time management. These lessons helped us achieving 100% completion in the following sprints. So for the sprint two, so this Panajan shows our progress during sprint two. We started with 44 story points and completed all 44 by the end. Sorry, Panjot. So it shows a decline from 44 to 0. In the first few days, we made a good progress. Then we had a gap in the middle of the sprint due to sprint break, which is reflected in the flat part of the chart where no tasks were completed. After the break, we resumed our work quickly and got back on track. However, we weekends slowed us resumed for quickly and got back on track. So it recovered and completed everything on time. Overall, our actual progress closely followed the ideal line, and we achieved a 100% completion rate. This shows that despite of this break and some downtime, our planning and teamwork helped us to finish strong.
And here comes to our Sprint3 backlog. So as you can see from here in our current work sprint, we're focusing on 5 main tasks, and we're making reports that patients can download and share. And we're also making the system faster, results in under 2 seconds. And we're adding different user roles like doctor, patient, and admin. And we're also making sure that AI is right at least 90% of the time. And we also want to we're making it easy for patients to see their own health data quickly. And we're also adding arrow tracking to fix problem faster.
Yeah, coming to Sprint 3 test cases. First we have checked the download if the PDF reports are getting downloaded and it got passed. Next is image speed test. In this test case, we checked if images are processed in under 2 seconds and all the images were processing perfectly and this passed the test. Next is user role assignment, where in this test case we confirm users get correct roles like doctor, patient, or admin during login or registration, and the test case got passed. Next is dashboard visibility test. We made sure users you see the correct dashboard based on their role. Everything showed up correctly when the user get logged in, and it got passed. The next is unauthorized access test. We tried to access restricted areas to check security, and the system is blocking when the restricted areas got checked and the attempt get properly passed. And the next is AI model accuracy test. We tested the AI model performance and achieved 91% accuracy above over 90% goal, and it got passed. Next page. The next is web accessibility test. We checked if the web app works properly, and it got worked properly in all devices like computer, tablet, and phone, and it got passed. Next is we triggered backend errors to see if they were logged correctly without crashing the app. Errors were recorded successfully, and it got passed. The next is front end error and ensure checked if they were logged properly without breaking the app, and it got passed. The last one is critical failure and verify system stability and notification. And all these admins were notified and the system did not crash, and it got passed. And all functional and technical test cases in Sprint3 passed successfully. And we have done all the test cases without any fail. Next slide.
In Sprint 3, our team completed six important tasks, adding up to a total of 34 story points. First, we worked on user story 11, which is given 5 story points, where we allowed patients to download their diagnosis reports easily so they can share them with doctors. Next, in user story 12, which is given 8 story points, we made the system faster so researchers and doctors don't have to wait too long for their results. In user story 13, for 5 story points, we built a role-based access system, which means doctors, patients, and admins each get the right access and features. Then user story 14, which is given 8 story points, we worked on making the system highly accurate to make sure doctors can really trust the diagnosis. In user story 15, which is given 5 story points, we made the system available online so patients can check their reports from anywhere. Finally, for the technical task, technical story 5, which is given 3 story points, we added logging and error handling to help monitor and catch any system issues early. Next slide, please. For the Sprint3 metrics, our team velocity was 34 story points, which means we completed all the work we had planned. Our completed committed ratio was 100% as we finished exactly what we committed to. Looking at all three sprints together, our average completion rate across the project is now 90.20%, with Sprint 1 at 70.59% and Sprint 2, Sprint 3 both reached 100%. Next slide, please. The chart shows our historical team velocity over the 3 sprints. In sprint 1, we completed 12 story points on a scale of 15 story points, which was a slow start as we were still setting up the project, getting used to tools and defining our roles. Because of this, we couldn't finish all the tasks we planned. So we ended with a 70.59%. In sprint 2, we improved a lot and completed 44 story points out of 44. After having a strong base ready, we completed all work as planned. In Sprint 3, we finished 34 out of 34 story points. We kept the momentum, improved the system further, and again completed all the tasks. So we ended Sprint 2 and Sprint 3 with 100% completion rate. Moreover, the red dashed line shows that our average work done per sprint was 30 story points. And you can clearly see that in sprint 2 and sprint 3, we stayed above average, proving that the team became faster, more stable as the project went on. And the next slide will be explained by Ramesh.
Coming to the rundown chart, in Sprint team initially faced delays and didn't start work right away. During the early part of the sprint progress was slow with work happening only on alternate days. However, starting from April 19th, we picked up the pace and worked consistently every day. The shift is in momentum allowed us to recover quickly and complete all planned user stories by the end of the sprint. The Bunran chart reflects this pattern, and flat line at the beginning gradual drops on alternate days, and a sharp steady decline after the April 19th. We successfully completed 30 points and achieving a 100% completion rate and showing strong collaboration and deep time management in the later half of the sprint. So next slide. So coming to the retrospective, what went well is, can you zoom this?
Yeah, sure.
What went well
Oh,
is
sorry.
the team yeah, the team collaboration went well. Knowledge sharing helped speed up the process, and we helped each other when someone was blocked, and smooth interaction of our individual parts. So what can be improved is some tasks took longer than we planned, and the time management should be improved, and documentation can be also improved. So coming to the what can be action items. Yeah, in the action items, uh, set strict time box for meetings to keep them short and efficient, and to maintain a clear and updated task board daily. And we need to adjust our time estimations in the future.
Coming to the screenshots. So this is the preview of our application interface. So the platform is designed for rapid AI-based diagnosis of pneumonia and the brain tumor. On the right, you can see the model in action, processing it nearly complete, and the system has confidently detected pneumonia with 95.8% accuracy. The interface is clean with quick access to start or learn more, making it more user friendly for the healthcare professionals. Our goal here was to combine the powerful AI with a simple design that supports the timely medical decisions. So the next slide is the login page. So here it allows the users to securely sign in using the email, password, or third-party accounts like Google and GitHub. So this user-friendly design ensures quick access for the healthcare professionals, supporting their need for efficiency and ease of use. So the next slide. So here the screen shows the Google sign-in option for our application. It enhances the user convenience by allowing healthcare professional to securely log in with their existing Google accounts. This aligns with our goal of creating a efficient user experience as highlighted in the front-end development efforts mentioned in our previous presentation. The next slide. Here, the screen displays the scan analysis results for the patient. It shows key metadata like scan date, patient ID, and the status, along with the AI diagnosis. So, in this case, no tumor was detected. Users can view the result, generate the report, and upload the another scan. So, this reflects the core functionality we implemented and where we focused on backend integration and real-time result. So the next slide here, so we developed the automated report generation feature. The screen displays the formatted PDF style output summarizing the results of the brain scan analysis. This report includes patient's information, scan metadata, and diagnosis details. We ensure that the report pulls directly from the analysis system and maintains consistency with the UI results. Even though some fields are placeholder values right now, the structure supports dynamic data integration for real use cases. This allows both doctors and patients to download the print formal diagnostic summary. So the next slide here it showcases the chest X-ray module added in the Sprint 3. Users can upload the X-ray images, input the patient details, and receive the instant analysis. In this case, pneumonia was detected with 85% confidence. The system flags the condition, offers the option to view the detailed report. The next slide is the detailed diagnostic report generated after the chest X-ray upload. Here it includes the patient details, scan metadata, and diagnostic summary. The AI model detected pneumonia with 85% confidence as shown in the right panel. The bottom section provides the downloadable radiological report with time-stamped exam data and clinical notes, ensuring that there is a good clarity and traceability for the medical professionals.
And here comes to our API endpoints. These are some API endpoints we're using in our projects, and we divided them into three sections. The first one is authentication APIs. So as you can see, our system needs to know who's using it, and we let users sign in with Google or for quick access. We also have regular email and password login, and users can see their own profile information. And new users can also create accounts easily. And here it comes to our the management APIs. And here's how we handle scans. User can see all their scans in one place, and they can upload new scans. They can also look at the details of any scan, and they can check if a scan is still being analyzed. And they also can create PDF reports to download or print. And the third one is our machine learning model APIs, and our AI like brain is simple to work with. So we have one main way to analyze brain scans, upload the scan, and it tells you what it found. Simple. It's very simple. And here's our wiki page link here. We have more detailed user manual and deployment manual in our wiki page. And thank you. This is Team The Minions. Thank you.
Thank you.
Thank you.
Thank you.
All right.